In this video, we're going to talk about the Sieve of Eratosthenes. This is an algorithm for finding smaller prime numbers. Let's suppose we have some number n. The way the sieve works is that we take the square root of n and then look at all integer multiples beginning with 2 and ending at the square root of n. We remove those integer multiples from our list, and the numbers left remaining are prime numbers. Let's look at an example. Let's consider the number 81. We know that the square root of 81 equals 9. Therefore, we're going to look at all integer multiples between 2 and 9 and remove those from our list. Before we get started, let's remove 1 from our list right away, since 1 is not a prime number. It is not necessary to look for integer multiples of 1, because that would have the effect of crossing every number off of our list. So let's start with integer multiples of 2, excluding the number 2 itself. We remove all integer multiples of 2 from our list. Next, we evaluate integer multiples of 3, excluding 3 itself. It's not necessary to evaluate integer multiples of 4, since those were all removed when we looked at integer multiples of 2. Let's look at integer multiples of 5. It's also not necessary to evaluate integer multiples of 6, as those were found when we evaluated integer multiples of 2 and 3. Let's look at integer multiples of 7. We'll remove them from the list. Oops! We don't want to remove 7 itself. So 14, 21, 28, and so on. Our list of remaining values represents the prime numbers, less than 81. And I do see I accidentally crossed off 5. Again, we were removing integer multiples of 5, not including 5 itself. Our integer values remaining are all of the prime numbers less than 81. So you can see that the sieve is very useful, but if your number n gets too large, using the Sieve of Eratosthenes can be pretty inefficient. However, it works beautifully for finding smaller primes. This concludes our example. I hope you found it helpful. See you next time.